So I think we can get started. Can everyone hear me? Cool. Welcome to this talk on rigorous and multi-tenant Hbase performance. My name is Govind Kamath, and my co-presenter is Yanpei Chen. Both of us are members of the performance engineering team at Cloudera. But as you might notice, we have a difference of opinion on an important topic, whether data is the new tofu or the new bacon. Other than that, here's a brief bio. I work on Hadoop and Hbase performance, and my experience has been in simulators and electronic design automation software. Yanpei works on multi-tenant performance at Cloudera with components like MapReduce, Hbase, Impala, and Search. And he graduated from Berkeley, where he focused on performance, theory, and method. Sorry. So here's the agenda. I'm going to do the first part of the presentation, dealing with rigorous Hbase performance measurement. And Yanpei will follow with the multi-tenant aspects of performance, where Hbase is just one component in a multi-tenant cluster. So I'll go through a brief overview of Hbase, talk about how one goes about measuring performance, go through the mechanics of using YSBE, and then talk about how to get reliable performance measurements, the best practices for doing that. Yanpei will then cover the multi-tenant aspects of performance. So since this is Hadoop Summit and not HBaseCon, I think a brief overview of Hbase would be in order. So it is a distributed NoSQL key value store, where it is almost like a sorted map or a sorted table, lookup table. Now, that is a lot of buzzwords, and I like to keep it simple. So how many of you have used the book? And you might ask, which book? Let's say the phone book or a telephone directory. I think it's not a lot of you at this time. So imagine that your day job is looking up entries, phone numbers in the phone book. And so you're pretty sick of this job very soon. So you have the bright idea of hiring 5 college students. And since you just have one phone book, you decide to divide it up into 5 pieces, tear it up, the first section going from A through E, the second one F, G, H, I, J, and so on. Obviously, if I was one of those college students, I was lazy, then I would choose X, Y, Z, but that's another matter. So once you have done that, you find that you would expect that performance would increase maybe 5 times since you have 5 students there. But as a matter of fact, you notice that it goes up more like 10 times. And the reason is that each of these students has a much smaller section of the phone book to deal with. And they can memorize entries like those for, let's say, Obama, Jennifer Lawrence, and so on and so forth. So they can do a much more faster turnaround time. Now you replace the words college students with region servers and think of it as a distributed system. You yourself are the master or zookeeper directing the clients to the appropriate machine. And you got pretty much a picture of Hbase. Obviously, it's a little bit more complicated than that. In the case of Hbase, you're going to be able to write entries to the table in addition to just looking it up. But that's the general gist of the picture. Hbase is built on top of HDFS, which takes care of fault tolerance and replication. Now, when talking about Hbase, the most common question that people have is, but what is the performance? And so you go to the internet and take a look at performance, and you find numbers that are all over the map. There is really no consistency. The numbers vary widely. And so you go ahead and try to get your own numbers for your own application, for your own cluster. And very soon you discover that performance depends a lot on several factors. It depends upon the cluster you have, the amount of memory you have, the test beds you use to measure performance. It also depends upon the workloads, the kind of load that you're imposing upon the cluster. Hbase has a ton of configuration parameters. All of them can affect performance significantly. And the region servers change in state as you write data into them. So what can you do to get better performance data? So at Cloudera, we try to track the performance of various components in our distributions. And with the case of MapReduce and Yarn and so on, we have nice flat graphs where performance is very steady day to day. This is over a period of several months. When we tried this with Hbase, we saw very significant variance. Now, the intent is not to see exactly what the throughput and so on are, but you can see the trend that it was very hard to pin down performance. At that point, we decided that a more rigorous methodology would be required to handle Hbase in particular. So how do you measure performance? The first point is that you actually need a workload to use against Hbase. And a workload is simply a set of transactions that you would use. This could be reads or writes. In the case of reads, it could be reads of individual keys. It could be scans of ranges of keys. In the case of writes, you could either write data directly, insert an entry, or you could update an entry. You could choose to have mixes of these transactions, and that comprises your workload. But a workload also has a couple of other components. You don't start a set of transactions directly against an empty data version of empty installation of Hbase. You actually would want to load initial data first, and that data is just as much part of the workload as your transactions. The other point is that transaction intensity, the intensity of the transaction that you're imposing on the cluster, can vary over time, and that is something that you want to factor into account as well. There are several workloads that are possible. Perhaps the most ideal would be the workload that is most applicable for you, your own workload. And that sounds as though it would be the best, but in reality, when you try and use this, it is very hard to abstract out the transactions from your running application. It may be fast, it may not be easy for you to actually go ahead and change the intensity of these transactions. And once you have the real workload, conditions might change. It might be different at a different time. So all these factors mean that you might decide to use a synthetic workload. The other aspect of a synthetic workload is that you might find something that gives you an infrastructure to actually report latency metrics, throughput metrics, and so on. One that comes with Hbase is called performance evaluation. It's bundled in. You don't need to build anything. However, there are several limitations with performance evaluation. It doesn't allow you to change the request distribution. You cannot change the keys and the values. And there isn't really very much reporting that you can get back from performance evaluation. So YSBE, or the Yahoo Cloud Serving Benchmark, has become quite popular to measure Hbase performance. So let me go into a little description about YSBE. This was developed by Brian Cooper when he was at Yahoo Labs. And it's a performance evaluation framework, not just for Hbase, but for any generic key value database. So there are modules in YSBE supporting Hbase, Cassandra, Accumulo, and Voldemort. And you could write your own for any other database. So the nice thing about YSBE is that it separates out the client from the database interface layer. And the client has specific functionality, which is very flexible and configurable. You could choose to change the request distributions. You could choose the length of your test and the kind of reporting that you want to get. YSBE comes with a core workload, a standard workload, which is the set of transactions I told you a moment ago, reads and writes pretty much, and scans. But you could go ahead and add your own workloads, add additional functionality in a fairly straightforward way. When YSBE is done with a run, it will report throughput and latency metrics, and we'll take a look at that in a moment. So here's how you would go ahead and use YSBE. The first step is just to create a table when YSBE calls it user table. And there is the little incantation that actually starts YSBE up. You could choose either to use YSBE in the load mode, where you are loading data into the database, or you run transactions, and those are the two options. The other ones are a set of parameters and properties that you could specify to YSBE. In this particular case, we say that the column family that we're using for Hbase is CF. We want 1 million transactions, that's the operations. And you can bundle a lot of parameters into a file, and here it's called random write, so there are more parameters in that file. When you run YSBE, what you typically would do is to run the workload not just from one machine, but perhaps many machines. So you'd fire off YSBE jobs on several machines at one time. And you could choose to have multiple threads for each of these instances. In this particular case, for this particular one run of YSBE, we have 10 threads. And the last flag is just a status flag, which gives you a status report every 10 seconds. So here is a listing of some of the parameters that YSBE has. And they include the number of fields you have, the size of the records, the number of records, the number of transactions, and the mixes. You can say, I want to have 50% reads and 50% writes, and so on. So those are the proportions that you see in the third line. Finally, the last line tells you that you want to run it for maybe an hour. That's the execution time. All this is available in the YSBE documentation. So it's pretty easy to look up. And when you run YSBE, the first part of the screen shows you the output, the tail end of the output. And after the transactions are done, it gives you a set of results. And in the middle of that, you see that there were 3 million operations that were run. And it gives you the throughput. It says that the throughput was 2,247 operations a second. And based upon the size of the data, the records that you were using in your test, you can then compute the throughput. Typically, you would go with megabytes a second for a region server. The bottom of the screen shows you latency metrics. It gives you average latency, and then it also gives you percentile latencies. This gives you a good idea about how the run progressed and how well it did. This is the second part of the output, where the nice thing is YSBE gives you a histogram. And it tells you how many operations fell into different buckets. So the left column tells you these were all read transactions. The middle column tells you the time slot. So for instance, the first one says from 0 to 1 millisecond, we had 2,168,000 operations. And between 1 millisecond and 2 millisecond, you had 445,000 operations. So this gives you a good idea about the time slots in which most of your transactions actually fell in. When you're running a performance test on Hbase, there are a few steps that you need to take right up at the beginning, and these are fairly obvious. In the beginning, you need to set up your cluster, install Hbase on it. Once Hbase is installed, you would want to configure it properly. Then you create the tables that you would want to use. You probably would want to split the tables into segments, into regions. And finally, you would want to load the data. Now, with each of these steps, there is a good way to do it and a not so good way to do it. So it's good to make sure that you follow the guidelines here, follow the best practices in getting everything set up very well. So with regard to setting up your cluster, the first point that goes without saying is to ensure that you're using the right hardware for your application. Now, there are guidelines on this, but ultimately you would need to know what the amount of memory is. This is the most crucial factor that determines Hbase performance. So you want to decide upon the size of memory for your nodes, the number of disks and I/O channels that you're going to use, and so on. The next point that you need to keep in mind is that with any Hadoop cluster or a Hbase cluster, there are master services and master roles and worker roles. So the master services would be, for instance, the job tracker, the resource manager. You would have, in the case of Hbase, you would have the Hbase master. You would have zookeeper. And you want to keep the nodes that run these services separate from the ones that are being used for the region servers. what you're running in your performance tests is to evaluate the performance of the region servers. So you want to make sure that if they are loaded, they don't get affected by the master services. Similarly, if you're running MapReduce, you might want to consider not using the region server nodes to run your MapReduce jobs as well. So an easy way to do that is to kill the task trackers or the node managers that are running on the region server nodes. Then jobs would not be scheduled. Tasks would not be scheduled on those nodes. Similarly, when you're running performance tests, you would be having a set of nodes to run your clients on. For example, the ones that you're going to use YSBE on. And with the same arguments as before, you would want to keep the clients separate from the region servers. One way to cause issues in your results is to have additional load on the region servers that doesn't really become part of the Hbase computation. With regard to Hbase, as I said, memory is the most crucial point. So on the read side, it's the size of the block cache. And on the write side, it is the size of the mem store. These are the two components. And these can affect performance significantly. So based upon how you're using your Hbase installation, whether you are primarily reading data or you're writing data or you're doing a mix of both, you divide your memory up appropriately into fractions for these two. There are also a number of configuration parameters that Hbase comes with that affect performance, including Bloom filters, deciding whether to compress your tables, specifying the compaction parameters, whether to turn on short circuit reads. There are pros and cons for some of these, and you need to decide what is best in your case. But once you decide that, that is going to fix your performance results. The size of the data set should be proportional to what you expect to see. If you're running a large cluster and you're scaling it down, you need to scale down your data set accordingly and correspondingly adjust the number of regions you have. And it goes without saying that one of the most important points is to keep watching the health of your cluster as your performance tests are going. If there's an issue with one of the region servers, you need to track it down and fix it right at that point. It's not always easy to do this, but if you use a dashboard like Cloudera Manager, it becomes a lot easier. So here, this is a chart from Cloudera Manager, and you can see that you have a bird's eye view of cluster CPU, the disk I/O, the HDFS activity. You can see the number of jobs that are running. You can see how many read transactions are getting into Hbase, how many write transactions are entering, and so on. So you can look at the block cache hit ratio. It becomes hard to grovel through all the region server UIs extracting this data, but using a dashboard like this makes life a lot easier. If there's an issue with Hbase, for instance, you'll probably see the green dots on the left turn orange and red, and then you can go and investigate. So once you want to start your test, you want to load your data into your Hbase cluster. And there are several options for doing that. One option would be to say, I'm just going to operate on my production cluster. I want to see how well it does. So there's really no loading to be done, and you're home free. The other option is to use a custom loader that you're using for your case. Performance evaluation can write data into your database. You can choose to write it in sequential mode or random mode, and that's an option to load your data. But probably the best way is to go ahead and use YSBE, because YSBE has a load option, and you can specify exactly what you want to get loaded in there. However, that can take time. One last option is to generate the H files directly. This is the native format that Hbase uses. So you can have H files created, and then Hbase can just slurp them up because they are in Hbase's own format. And that process is called bulk load. There are different utilities to do that. Matteo Bertozzi had one called H-file generator. So that might work for you. Once you think that you have loaded your data, before you load your data, there's one point to keep in mind. And that is to decide upon the number of splits you want to make to your Hbase installation, the number of regions. Now, as Hbase regions increase in size, it will go ahead and try and split the regions when they become too large. So there is an option that tells Hbase what the size of the file should be before it splits this. However, the process of actually splitting these regions is a very intensive operation. There's a lot of data that needs to be read and written, and your region server's performance goes down the pipes. So you may want to consider, since you know your own application the best, you may want to decide upon the splits beforehand, because you know when you're running, this is the number of regions you expect to see eventually. And you can pre-split your key space into those number of regions. There is a utility called region splitter, which will do this for you. And it depends upon the kind of keys you have. If your keys in Hbase are all strings, and if your strings could take any value, including, let's say, non-printable characters, then you would use the uniform split option. However, if you want nicely structured keys, and you might say I want them to be numbers, or even precisely hexadecimal numbers, then you would use the hex string utility. In the case of YSBE, it's neither of these. The keys are very specific. They go from user 1000 to user 9999, and that's much harder to split. So here is a little one-liner, actually a three-liner you can see there, that you can use on the Hbase command line. Unless you're a Ruby expert, I wouldn't suggest you take a look at it in detail. But if you know the number of splits, the number of regions you want, just substitute the number 50 with the number of splits you want, and voila, you have all the regions nicely set up. This is from Luke Lu, and I made some modifications to it to make it more accurate. And it makes your YSBE runs much easier. The last point is just to ensure that your trigger for Hbase to split regions is disabled. And you do that by saying, I'm going to set this value to infinity. Don't split my regions. So now that you have covered your bases on setting up the cluster and installing Hbase and so on, the next step is to look at how you can get reliable, repeatable performance measurements. And there are a few techniques that we have found worked well for us and work well in practice. And we'll go through this one at a time. So the first one is keep the input data set fixed, warm up the cache, set the target throughput, and use the correct distribution. Now, with regard to running YSBE performance tests, as I talked about this before, you load data into your database. And when you do that, there are several issues that can go wrong during that step. Typically, what you expect is, at the end of the process, you have a nice, evenly distributed data set across the regions. And that's how you would want it in practice. But what happens is region servers don't always operate at the same rate. There may be machine problems. There may be slow disks. Some region servers might be under load. Some of them might load the data faster, and others might have issues. Similarly, the client machines, on the clients, you might have some clients that go into garbage collection. Some of them are faster, and maybe one of them terminates abnormally, and you would be none the wiser for it. So at the end of the load process, the expectation that you have that your data set is nicely, evenly distributed, and reality could be that it's far from that. So it is essential to make sure that your data set input data set is fixed. So easy way to do that is to load your data once, make sure it's all OK, and make a copy of that data that you're going to use for your performance tests subsequently. If you save the H files away, every time you start your performance measurements, you can restore that. This had the effect of quieting down our graph that you saw earlier quite significantly. So it goes without saying that keeping your input data set fixed is of the paramount importance. All it says is that you don't want to go on a wild goose chase trying to track down problems that really don't exist by getting out of the gate too early. So this is the graph I showed you before. Once we made sure that our input data was very consistent, it had the effect of quieting this graph down very significantly. It didn't fix everything, but then we saw a much better behavior from then on. The second point to keep in mind is to warm up your cache. As I said, Hbase is a very memory-intensive citizen of the cluster, and performance depends a lot on memory. So what you want to do is to start your runs, make sure you're on the read side, you load pretty much the entire data set as much as possible. On the write side, you write data until store files get created and start getting flushed and compacted. All of these processes will affect your performance quite a bit. So what you want to do is to carry out long-running tests and repeat these tests until you find that steady state has been achieved, until you can start getting repeatable results. And that will happen when you have long-running tests that get started after a significant amount of time. So here is an example. I mean, in this particular case, there are several runs. So we have throughput and latency. The red line shows throughput, the green line shows latency, and you can see that they flatten out after a certain number of runs. The other point to keep in mind is to decide the intensity of the throughput that you want to impose upon your cluster. YSBE gives you two options. One is the number of threads that you have, and the second one is the target option. So typically what you would do is you would have a large number of threads that could potentially stress the cluster to its limit. But then you scale it back and throttle it back using the target throughput. So actual throughput that you see will track the target throughput. And as you start increasing the target throughput, actual throughput will level off at a certain point. So that point defines the point of saturation. And as you can see here, the y-axis shows you the actual throughput, and the x-axis is targeted throughput. As we increase the targeted throughput, the actual throughput rises until it flattens out. Latency degrades, but it can degrade even after the point of saturation. It's important for you to identify this point of saturation, because that is going to be what determines the performance of your Hbase installation. Finally, when you perform your Hbase run, you want to use the right distribution. There are several distributions that YSBE provides, including a uniform distribution, a latest distribution, and hotspot and Zipfian. So this is just a recap. And now let me call upon Yanpei, who will take you through the nuances of multi-component, multi-tenant Hbase performance measurement.
Hi. Is the mic working? Good. All right. Thank you, Goldman. Could some of the facility folks take care of the aircon? It's getting a little bit loud. All right. So, okay. Yes. Multi-tenant Hbase performance. All right. Before that, as Goldman mentioned, I believe in bacon makes everything better. Goldman likes tofu. I like bacon. So yeah, bacon makes everything better, just like data. Hence the T-shirt. Anyhow. Multi-tenant performance. When we say multi-tenant, we mean multi-tenant as in multiple compute frameworks. This is necessary for several different reasons. Increasingly, enterprises want a single data repository where all of their data is stored, secured, managed, and governed. At the same time, the community has come up with a set of different compute frameworks, each specialized for a different kind of data access. For example, Hbase, the focus of this talk here, is specialized targeted at real-time serving applications. MapReduce, on the other hand, a different framework specifically optimized for batch processing. And there are several kinds of these frameworks existing today. Now, the combination of those two trends, single data repository or data hub, multiple compute frameworks, means that eventually we will have multiple frameworks examining, interacting, analyzing the same data at the same time, hence multi-tenant environments. Now, the focus of today's talk, I will be speaking about a real-life multi-tenant use case that customers are already using today. The use case is we want to do free text search on the data that's already in Hbase. Customers want this because Hbase is a workhorse through which a large volume of highly valuable data lands in the data repository or data hub. Now, the data is valuable enough that it deserves to be analyzed and interacted with and explored through mechanisms, techniques, more than just a key value lookup. It is multi-tenant because it involves Hbase, MapReduce, and Cloudera search, which is just Apache Solr. MapReduce is involved because it is used to index data that's in Hbase into Solr. Now, this is a close cousin of perhaps the most well-known MapReduce use case, that is indexing internet data to facilitate free text search of the web. The performance challenge is to make sure that the indexing does not impact Hbase and Solr performance. Now, multi-tenant performance is hard. There are some inevitable constraints. We are asking the same shared hardware to do different kinds of processing, to do additional processing on still the same amount of hardware. Now, it's inevitable that when resources get shared, that the performance won't be as good as the standalone performance of each framework operating by itself. Now, then the performance question becomes, what is the gap between multi-tenant performance and single standalone performance? When we say this gap is small, when we say the system has good multi-tenant performance, we are really saying several different things. We are saying that the aggregate performance across Hbase, MapReduce, Cloudera search, multiple frameworks, the aggregate performance is good, or the cluster behavior is efficient. We are also saying that the performance of each, it reflects the policy assigned of shared resources. In other words, the cluster behavior is fair. We are also saying that as workloads change, as new processing arrive, depart on the cluster, that each framework gets the resources it needs very quickly, and it relinquishes those resources once it no longer needs them. In other words, the cluster behavior is elastic. So you can see multi-tenant performance, a very, very simple phrase, but once you get into it for real, the meaning of that gets elaborate quite quickly. Now, practically doing Hbase to Solr indexing via MapReduce, that has several different steps, challenging steps. What Govind talked about setting up Hbase, configuring Hbase, guess what? There's a parallel process for search for MapReduce. Govind covered a large set of performance-relevant parameters for Hbase. There's an equally large set for Solr and for MapReduce. Also important, we need to configure each of the frameworks to achieve a specified policy resource shared. A difficulty with that is some of the resource sharing controls are implicit. In order to control this resource, we have to turn a seemingly unrelated knob. Now, this is the artifact of each of the frameworks initially being designed for a standalone rather than multi-tenant environments. Also, as Govind covered, for Hbase, we need to pre-split the table, set up the regions to set up the data sets to ensure high performance. There's a counterpart process for that for Solr. But instead of regions and tables, we say shards and collections. Once we got all that taken care of, we start with getting a baseline for standalone performance. Now, this means we compare MapReduce indexing for Hbase MapReduce into search via the more standard process of indexing data that's already resident in HDFS directly into search. Important because we want to quantify that the overhead of going through Hbase is small. Graphically, it looks something like this. This is a graph showing resource utilization across time. We start with Hbase, MapReduce, and Solr, all three frameworks being idle. The indexing starts. It consumes up to the full capacity of cluster resources. After it's done, Hbase, MapReduce, and Solr becomes idle again. Now, this is just to get the baseline. When you do this for real in a production environment, of course, Hbase and search, they will be serving transactions and queries at the same time. Now, this becomes much more interesting. You can see that MapReduce indexing, it takes longer because it consumes only a share of the cluster resources. Question is, how much longer? If we direct through targeted throughput, Hbase, and search, we direct a sufficient workload at the cluster should be fully maxed out. We can check for efficiency by verifying that the cluster resources are indeed fully utilized and whether that's reflected in Hbase and search performance. The indexing starts. We check for elasticity by seeing whether MapReduce job can acquire the resources it needs quickly. The indexing completes. We check for elasticity again by seeing whether those resources are relinquished quickly. At the same time, elasticity means Hbase and search, they get the resources that get relinquished very quickly. So what is transient Hbase and search performance? How does that behave? We also check for fairness by comparing Hbase, MapReduce, and search performance against the standalone counterparts. For example, if the policy is to say Hbase, MapReduce, and search, they get a 1-to-1-to-1 share of the cluster resources, then arguably we should expect that Hbase, MapReduce, and search, their multi-tenant performance will each be a third of the standalone performance. There are a lot of technical and numerical details that I've intentionally left out, but I hope this graph gives you a sense that when we talk about multi-tenant performance for real, it's much more than just checking a box for feature complete and much more than just throwing out a single performance number. Okay, so recap. Hbase is an essential but not the only component in the enterprise data hub. There is a need for multiple frameworks, including MapReduce search, to interact with and analyze Hbase data. We hope you are all convinced now that it is challenging to define and measure multi-tenant performance. Everything that Govan has talked about earlier in the talk, rigorous method for measuring performance of a single framework, that has to be repeated for different frameworks and that forms the foundation for measuring and understanding multi-tenant performance. To conclude, we hope that this talk gives us a sense that there is a very, very rigorous discipline and science to performance measurement of Hbase, of other frameworks in the big data ecosystem. This is what you should look for when you come across performance numbers in the trade press, and I hope you will always expect the same standards from us. Thank you, ladies and gentlemen. We have some time left, so we're happy to take questions. Yes, sir.
So when we use the tool YSBE, can we ingest our own data and our own schema using YSBE as a tool to ingest our own data?
Yes, it's quite flexible to modify YSBE. I mean, YSBE is an option to load to specify generic keys and values. And you could change the schema that you want to use. It's fairly straightforward to do that in YSBE. Once you do that, then YSBE can be used to upload your data into Hbase as well.
By the way, the question was, can we change YSBE to load our own data and schema?
Yes, yeah, YSBE is open source, so you can download it. It's fairly easy to find out the portion of the modules that actually load data in there, and you can change the schema.
Other questions? Yes, sir.
Yeah, to qualify the test, you said don't run the region server and the MapReduce test tracker on the same machine. But in production, is that okay, or is that a no?
Okay, so the question is, we said in our slides to don't run the region servers and MapReduce task trackers together in production environments. How does that work out? I think it will change depending on your use case. If you segregate the clusters, the compute part of the roles, then you will possibly get a reduction in the, how to rephrase this? You are setting a hard divide in the cluster. You will get a decreased capacity in each framework. If you're okay with that, fine. But when for example, Hbase is idle, but MapReduce is doing a lot of processing, MapReduce will not be able to take advantage of the Hbase resources. So it's pros and cons, and it will be up to your environment.
The issue I have now, when they're both busy, the reserve dies, right? Because it defaults clauses and down it goes. So I was asking, okay.
So the follow-up comment was in the production environment, if they are co-located, then there are garbage collector type issues and the region server dies. How do we deal with that? So that goes into ensuring proper configuration, ensuring you have enough RAM, so on and so forth. Now, cluster misconfiguration on the resource sharing front, that's a difficult topic and is commonly done poorly. Cloudera Manager has a set of safe defaults that you want to increase for high performance. But in general, be patient. There's a lot of details that probably is an elaborate hour-long talk in and of itself. We're happy to chat with you offline.
Any other questions? Good.
So how do you isolate the different workloads in the same cluster?
How do you activate the different workload?
Isolate.
How do you isolate the different workloads in
the same cluster.
Are you talking about from a multi-tenant perspective? Do you want to take that?
Sure. How do we isolate workloads? I guess there's a little bit of a loaded question. The intent of this multi-tenant environment is actually to not isolate the workloads. So you run all of the workloads on the same hardware at the same time, such that when any of them has spare capacity and the other frameworks have increased load, then the different frameworks can get the spare extra transient capacity as they need it. Does that make sense?
I think for MapReduce and Hbase, they are all very comfortable resources like CPU, memory, and even the I/O. And if there's no way to enforce the resource isolation, I think it would be very challenging to ensure the SLA of each of the workloads.
Right. The follow-up comment is if there is no way to ensure, emphasis on the word ensure, resource isolation, then it will be challenging for the frameworks to meet their SLAs. Yes, we agree that's the case. The details of how to do that is a parameter list. So far, yay long. We are working on a more, user-friendly way to set all of those settings. But it's to do with how do you configure the memory, the CPU, the disk, etc., parameters to control the share of resources between different frameworks. There's a set for MapReduce, there's a set for search, there's a set for Hbase.
Yes, each component needs to be tackled on its own, and there are throttling mechanisms for pretty much all these different components. And you need to find out what those are and adjust them accordingly.
Other questions?
Where we can see graphs or data about your result of your tests.
The question is, where can we see the results of our tests? Yes, we could have results of our tests, but the question is whether they are applicable to you. The Hbase performance can be very significantly different. We can get read access rates for random reads from 0.1 megabytes a second throughput to all the way to 50 megabytes a second throughput, depending on how much memory you have. So it's very hard to pinpoint one that is so-called the right performance number. It all depends upon the configuration you have and the setup you have and your application as well. So that's why we deliberately didn't put this up here. We do track our performance, but they're all relative. We have a baseline, and we track differences based upon that, because we know our cluster size, the kind of workloads we are using.
So to kind of rephrase the answer, our internal test is geared towards general tracking of performance of each of the components. But if you're looking for guidance for your particular performance, you should be very careful of anyone who's trying to sell you a single number instead of having a conversation with you about what is your use case and the pros and cons of various approaches.
Okay.
Okay.
I think we're running out of time. So thank you for
Thank you,
agreeing to talk.
everyone.
Yeah.